Good morning to one and all present here. Myself N. Kalpna. I am from Sri G.K.Jain High Secondary School, Roypuram. Today, for the 11th standard, I am going to explain the topic is physical and the chemical equilibrium. In chemistry, we know that the reactions, it is given in this form. Usually the reaction it will be in a single-headed arrow. That means the reactant will be form the product. If it is given in the single arrow means it never get back into the reactant state. Once if it is formed the product means it never get back into the reactant state. We have to see the some other example. Iron gets rusted. Banana gets ripened. If it is formed the product means it's never get. That means it has been happen in a single direction only. And the second thing, if sometimes if the arrow mark given in the double side means, it means double headed arrow means the reactant form the product, at the same time the product will be able to form the reactant also. Example, hemoglobin. In our blood we are having a hemoglobin and from the lungs the oxygen gets. If it is reacted with the hemoglobin, it will be formed the oxyhemoglobin. At the same time, the oxyhemoglobin has a capacity or the ability to get back into the hemoglobin with the release of oxygen. This is the example for the equilibrium. Now we have to see the two equilibrium, physical as well as the chemical equilibrium. First one is the physical equilibrium. We know that the three states, solid, liquid as well as the gas. First we have to know solid, liquid, at the same time it has been in the equilibrium state. First, solid in liquid. It has the simplest day-to-day life example. When you have the water molecules in the, if it is in a solid state means ice. The ice get converted into the liquid. That means if it is heated means it should form the product. At the same time, the water molecules, if it is freeze it again mean it should form the solid state, ice. So it is in the equilibrium state. Next one is liquid in vapor. Again the water molecule, if it is heated, it evaporated. That means it should form the gaseous molecule. At the same time, due to the condensation, the gas molecules will converted into the liquid. And next one, in the physical state, it has been divided into the homogeneous and heterogeneous. Homo means same, hetero means different. So in the equilibrium reaction, if it is a homogeneous means throughout the reaction, that means both the reactant as well as the product, it has been in the same state. That means gaseous state. When a hydrogen, gas, iodine in a gas state. To form the hydrogen iodine, it is also be in the gaseous state. So it should be the example for the gaseous molecule. And next one is a heterogeneous. Heterogeneous means the reactant and the product will be in a different phase. Let's see the same example here, what I am given here. Here, water molecule in the liquid state, when it is formed the product as a gas molecule. So it should be in a liquid, it should be in a gas. So it should be in the different phases. That is why it should be called it as a heterogeneous. Now we see the chemical equilibrium. So we know that what is meant by chemical equilibrium? Equilibrium means the reactant will occur the product, and as the product is also able to occur appear the reactant. Okay. Chemical. That means in the chemistry, in the chemical, with the help of the chemical, how would the equilibrium have been attained? So we have the two types of reaction, reversible and the irreversible. Reversible means it has been able to form the reactant. Irreversible means cannot be able to form the reactant. Now we have to see the graphical representation of reversible and the irreversible reaction at the state of equilibrium. If it is attained the equilibrium means what happened? So we have to see the rate against the time. Once the graphical representation, when the forward reaction, initially it has been increased. So initially it has been increased. Later on, as time goes, so the reactant, as time goes, what happened? The reactant has been slowly, the rate will be decreased. Rate is nothing else, the speed. So it has been reduced its speed as time goes. But at the backward reaction, it is already formed the products. So again it has been combined to form the reactant. So it gets increased. So for a forward reaction, as times go, it has been decreased. At the backward reaction, it goes increase. But have you noticed that at one stage, it has been having a single line. Single line, it means at that point, both the forward and the backward reactions occur the equilibrium state. That means after that, there is no difference in that. This means, so rate of forward reaction which is equal to the rate of backward reaction when at the equilibrium. The second graphical representation, it is also be against time versus concentration. So when the reactant, what happened? Again, when the times goes, the concentration is also be decreased. And next, the product will be increased. Here also notice that here the point. At that point, there is no increase, no decrease, because it means it has been attained the equilibrium. So after attaining the equilibrium, the reaction, there is no show any macro changes, macro reactions. Some micro will be there, but it never be happen the macro when it attain the equilibrium. Now we see the law of mass action. According to the law of mass action, just considered as an example, it is an equation. A, B, B. So capital A will be the reactant and the small letters of A and B is the stoichiometric. Stoichiometric is nothing else. It should be the number of molecules. For example, when I am taking a 2 molecules of hydrogen or 2 molecules of water. Here 2 is the stoichiometric, the number of molecules of water. Here a small a will be the stoichiometric of, that means the number of molecules of capital A. So let us consider this is the example reaction. Now we see the concentration. Usually the concentration is always be referred in the, it has been referred in this type of arrows. Okay, so first we have C. The concentration of A, it is denoted by this way, and the concentration of B, it has been denoted by this. Let's see the law of mass action. Law of mass action is nothing else, the rate of the reaction which is directly proportional. You already know, you should know that what is meant by directly proportional and inversely proportional. Directly proportional means it should be in this way. And inversely proportional means 1 by alpha, like proportionality symbol. Okay, if it is a directly proportional means it should be, if it this increase means it is also be increased. If it this decrease means it is also be decreased. If it is inversely proportional means it should be in a inverse order. Increase this reactant side increase means the product side should be decreased. Okay, now we see law of mass action. According to the law of mass action, the rate of the reaction is directly proportional to the concentration of reactant and its stoichiometric should be in the power. Have you noted that? So the rate of the reaction is nothing else, the speed up of the reaction. The rate of the reaction is always increase, is always directly proportional to the concentration of the reactant. Concentration of the reactant and its power should be in a stoichiometric. Concentration, if the concentration if you have increasing means the rate should be increased. If the concentration is decreased means rate should be decreased. Now we have to know about the equilibrium constant. So we know about the, we already know about equilibrium. What does mean by equilibrium? So when the reaction, if it has attained the equilibrium means there is no macroscopic changes at all. Okay. Now we see the equilibrium constant. What are the equilibrium constant? Kp and Kc. So first one is Kc. What does mean by Kc? K is the equilibrium constant. If in terms of concentration, it should be Kc. If it is means of in terms of partial pressure, that means when the reaction in the gaseous state means it should be in the partial pressure. That equilibrium will be expressed in terms of Kp. So we have to find the Kp and Kc for the equation. First we have to, let us assume this is the equation XA YB which gives equilibrium CCDD. You know that X is the stoichiometric of A. That means number of molecules of A. Now, according to the law of mass action, so what is the law of mass action? The rate of reaction which is directly proportional to the concentration of A, and its stoichiometric should be in the power. Okay. So now we have to show for the forward reaction. Forward means AB which gives CD. This is the forward reaction. So rate of forward reaction which is directly proportional. So it should be a directly proportional symbol should be there. So that you have to know the reactant only. Concentration of reactant, not that product. Okay. So if it is in the forward reaction means what is the reactant? AB or CD? AB is the reactant obviously. So rate of reaction directly proportional to the concentration of reactant and stoichiometric in the power. So this is the. Then when you are seeing the backward reaction, if you are seeing the backward reaction, what is the reactant? Either AB or CD. So CD is the reactant here. So for the forward, AB is the reactant. For the backward, CD is the reactant. So for the backward reaction, rate of reaction which is directly proportional to reactant and the stoichiometric in the power. So this is the thing. Next, at equilibrium, we know at equilibrium both the forward as well as the backward reaction which will be in the equal state. So forward reaction which is equal to the backward reaction. So AXBY which is equal to CC and DD. Okay. So forward reaction divided by backward reaction is again the reverse order CCDD by AXBY. Okay. And KF by KB. That means equilibrium of forward and equilibrium of backward. Okay. It should be in the equilibrium. Okay. We have given instead of KF and KB, we have given the symbol KC. K is the equilibrium constant. We know that concentration should be given in this type of square bracket. Okay. It has been given in the square bracket. So for instead of KF, KB, we have given KC. If it is given, that means the reaction will be in the gaseous state, means it has been included with the partial pressure, that means Kp. So the same thing will happen. Instead of giving the square bracket, you have to mention the P. So the same reactant PCC into PDD divided by PAX into PBY. So these are the equilibrium terms Kp and Kc for the examples of equation. We have to find it. Now we have given the example. In this lesson we have expected these types of questions. Okay. If they have given the equation, you have to find Kc as well as the Kp. Okay. First, this is the equation. CaCO3 which is in the equilibrium CaO plus CO2. You know Kc. Kc means product divided by the reactant. Here the product will be there CaO CO2 by CaCO3, and here it will be in the gaseous state SO2 sulfur dioxide. So that is why if it is given in this Kp means you have to be mentioned just P in place of, okay, instead of